Okay, so today we're diving deep into something I think every single software developer out there grapples with, even if they don't really realize it. Cognitive load.
Yeah, absolutely. It's that mental strain you feel, when you're just like wrestling with complex code.
Yeah, exactly. And we've got a ton of research here, actually, going all the way back to the late 1980s, looking at how our brains handle too much information, especially when we're coding.
Right. And the really fascinating part is even though coding can seem like abstract and digital, it's limited by our physical brains.
That's so true, and that's what makes this whole deep dive so interesting, right? We're going to find out why some code feels like a mental marathon, while some code is a breeze. And we're going to learn some practical ways to write code that's easier on everyone's brains.
And I think if we kind of zoom out for a second, these insights can impact not only how we code individually, but the entire software development landscape.
Okay, so let's start unpacking this by talking about a really fundamental concept. Our working memory has limits. It's like juggling. You can only keep so many balls in the air at once.
It's kind of crazy when you think about it. Even the most brilliant developers in the world, they're still limited by this, right? Everyone has a limit to their working memory capacity.
That's why trying to tackle a massive code base, it can feel so overwhelming sometimes, like trying to fit a whole library into a tiny little backpack.
Exactly. The question then becomes, how do those expert developers, how do they navigate these complex systems without, their brains exploding? The answer isn't some superpower brain. It's actually in how they use mental models, these things called schemas.
So it's like chess masters, right? They can instantly see patterns on the board and remember the best moves. They built this huge library of schemas from years of practice.
Exactly. Think of a schema as a mental blueprint. Like in coding, maybe it's a design pattern, a way to structure code, or even just understanding how a specific system works. The more schemas you have, the less you have to actively think about.
Which frees up your brain to focus on the really tough stuff.
Yeah.
There was this study by Sweller back in 1988 that showed that the biggest difference between novice and expert chess players wasn't how smart they were, but the sheer number of schemas they had. Their brains were actually wired differently because of all that practice.
That's really exciting, because it means becoming an expert in software development isn't about being a genius. It's about building this rich network of schemas through experience and learning.
Okay, so then how do we actually build these schemas? Is it just about coding more and more?
Well, it's definitely part of it, but there's more to it. We need to look at all the types of cognitive load we face as developers. The first one is called intrinsic load. That's the complexity of the information itself. Some ideas, they're just hard to grasp, no matter how they're explained.
So like trying to learn a complex algorithm for the very first time.
Exactly. Imagine like the difference between learning to ride a bike and learning to fly a helicopter. The task itself determines how complex it is. And unfortunately, we can't really change that.
So how do we deal with it then? Do we just grit our teeth and push through it?
Well, I think the first step is just recognizing that this intrinsic load exists. Helps us manage what we expect and be more strategic about how we learn. We got to break down those complex concepts into smaller bits, give ourselves time to absorb it all and build those schemas.
Okay, that makes a lot of sense. So what are the other types of cognitive load?
The next one's extraneous load. This is the mental clutter that comes from things outside the actual information, like trying to work in a messy room where you just can't find anything.
So like badly written code, confusing documentation, or those tutorials that jump all over the place.
Exactly. Extraneous load is a real killer because it takes away our precious working memory. Imagine trying to debug some complex code, and at the same time, you're deciphering cryptic variable names, and the whole thing is a tangled mess.
Ugh, I can feel my brain hurting already.
But the good news is we can control this. By writing clean code, good documentation, and designing intuitive stuff, we can clear this mental clutter and make software way easier to understand.
So it's not just about code that works, it's about code that's easy for humans to understand.
Precisely, and that's where all the good design principles and coding practices really come in.
Okay, so we talked about intrinsic load, which we can't change, and extraneous load, which we can reduce. What's the third type then?
The third one is, it's actually a good kind of mental effort. It's called Germane load. It's the focused concentration that helps you understand things and build those schemas. It's like going to the gym for your brain.
So it's challenging, but in a good way, because it leads to deeper understanding and knowledge. How do we actually increase this Germane load, though? isn't all mental effort basically the same?
Not quite. One cool technique that research has found is called goal-free problem solving. So instead of always trying to reach one specific answer, try approaching problems in a more open-ended way.
Can you give an example? I'm not sure I'm following.
Sure. Let's say you're working on a physics problem and you're trying to figure out the velocity of something. Instead of just focusing on finding that velocity, try calculating all sorts of other variables you can, like acceleration, momentum, kinetic energy, all of those.
So by exploring the problem more broadly, you're pushing yourself to think deeper about those underlying concepts and relationships.
Exactly. That leads to much better schema building. Imagine it's like taking the scenic route instead of always rushing straight to the destination.
I like that. So goal-free problem solving, check. What else can we do to boost this Germane load?
Another great strategy, especially when you're learning something brand new, is to dive into worked examples.
You mean those step-by-step solutions that show you exactly how to solve a problem?
Yes. It's tempting to just skip those and jump right into solving problems yourself. But research actually shows that for beginners especially, studying worked examples helps a ton. They give you a blueprint, so you're not starting from scratch.
So like having a master chef guide you through a complicated recipe, step by step.
Exactly. Don't just passively read through them either. Actively engage with the examples. Try to guess what's coming next, understand the reasoning, and even try changing the example a little to solve a slightly different problem.
That makes sense, yeah. It's like learning to play a musical instrument. You wouldn't just read about music theory. You'd practice scales and chords, too.
Right. And the more you practice, the better and faster you get.
So we've got intrinsic load, extraneous load, and Germane load. What else is there to know about cognitive load and how it impacts developers?
There are a few more things. One is the split attention effect, which happens when we have to constantly switch our attention between different things.
Oh, yeah, I know that feeling. Trying to follow a coding tutorial where the code, the diagrams, and the explanations are all over the place. It drives me crazy.
It's like trying to build some furniture, and the instructions, parts list, and diagrams are all on different pieces of paper. A recipe for disaster.
So how do we fight back against this split attention effect?
The key is to integrate information whenever possible. Combine your diagrams and explanations, write code that's self-documenting, and use tools that keep related information together. The less mental juggling you have to do, the better.
Got it. So streamline the flow of information, make things easy to find.
Exactly. And this brings us to another cool concept, the modality effect. Research shows that if we engage both our vision and hearing, it can actually help us learn and remember things better.
So instead of just reading a tutorial, it's better to watch a video with diagrams and a voiceover, right? Or even better, attend a workshop where you can see someone demonstrate the concepts in person.
Exactly. By giving our brains multiple ways to process the information, it sticks better. Imagine building a bridge with more supports. It's going to be much stronger.
Great analogy. So it's not just about reducing cognitive load, it's about using our brains in a smarter way. What else should we think about when trying to manage cognitive load?
One more crucial point is to avoid redundancy. While it may seem like repeating things helps you learn, research actually shows that it can make things worse.
Really? Why is that?
Because all that repeated information, it actually uses up valuable working memory and makes it harder to build schemas. It's like listening to the same song over and over again. Eventually, it just becomes noise.
So it's not just about explaining things clearly, it's about explaining them concisely too.
Exactly. And that's why the DRY principle, don't repeat yourself, it's so important in software development. It not only makes your code shorter and easier to maintain, but it also makes it easier for anyone to understand. This applies to everything, not just the code itself, but also to documentation and how we teach others.
Okay, avoid redundancy. Got it. What other cool insights can we get from cognitive load theory that can help us be better developers?
One last concept is called the variability effect. It's all about shaking things up, exposing ourselves to different examples and types of problems.
So it's not enough to just master something in one specific context. We need to be able to use it in different situations.
Right. Think about learning a new language. If you only practice with one framework or library, you might get good at that one thing, but you'll struggle with new frameworks and different types of problems.
Like training for a marathon on a treadmill versus training on real trails, different surfaces, different weather. You gotta be ready for anything.
Exactly. When we challenge ourselves with variety, our brains have to build more flexible schemas that we can use in many different ways.
So how do we do this? How do we bring variability into our learning and practice?
One way is to intentionally look for different kinds of coding challenges. Try new languages, new frameworks, new problem domains, even if it feels a little uncomfortable. Another way is to change up how you approach familiar problems. If you're doing web development, try different CSS frameworks, JavaScript libraries, or different ways of testing your code.
And don't just stick to coding either. Do other things that challenge your brain, like learning music, playing strategy games, reading about lots of different topics, anything.
Exactly. The more we mix things up, the stronger our mental muscles become.
Okay, we've covered a lot here. We talked about the types of cognitive load, how to manage it, and the importance of schemas. But how does all of this relate to the bigger picture of software development? Can understanding cognitive load really help us solve those big problems that developers often face?
Absolutely. Remember, software development is all about processing information. And as software systems become more and more complex, it gets harder and harder for us to understand, design, and maintain them. This is something that some people call the software crisis.
Okay, interesting. So how does cognitive load fit into this software crisis?
Well, every single choice we make as developers, from how we name variables to how we structure our code, it all has an effect on cognitive load. Code that's poorly written, not well documented, or badly structured, it creates a huge amount of extraneous load for anyone who has to work with it.
So bad code is actually making the software crisis worse.
In a way, yes. By understanding cognitive load, we can help solve this crisis by making code easier to understand and maintain, improving communication between developers, designing better user interfaces, and even creating better learning materials.
So if we're mindful of cognitive load, we can not only be more productive and write better code, but actually contribute to making the whole software world better.
Precisely. And that's a really worthy goal, isn't it? It really is. Now, some people might be thinking, like, okay, this is all interesting, but how do I actually use this in my work?
That's a great question. It's easy to talk about these ideas, but actually putting them into practice, that's a whole different thing. Let's say I'm trying to learn a new framework or a whole new language even. How can I use this cognitive load stuff to make it easier to learn?
Well, one of the most important things cognitive load theory tells us is that our working memory, it's really limited, especially when we're dealing with something totally new. So when we're learning, we got to avoid overloading our brains.
Okay, I get that, but how do we actually avoid that overload? I mean, learning new stuff is always going to be a challenge, right?
Yeah, of course. But we can make it less overwhelming by breaking things down. Instead of trying to learn everything all at once, just focus on mastering one piece at a time.
Like building a house, right? Brick by brick. You wouldn't try to lift the whole thing at once.
Exactly. And once you've got those individual bricks, you can start putting them together into bigger structures. So like if you're learning a new programming language, maybe you start with the basic syntax, then move on to data types, then control flow, and so on.
Building a solid foundation, step by step.
Gotcha. But then how do we make sure those individual concepts actually stick in our brains? Just memorizing stuff never really worked for me.
Rote memorization, it's rarely effective, especially for complex topics. The trick is to connect those new things you're learning to stuff you already know. Write them back to schemas you already have, make analogies, see the bigger picture. It helps you build a more connected understanding in your mind.
So it's not just about remembering facts, it's about understanding how they all fit together. And that's where those worked examples we talked about can really come in handy, right? Absolutely. By seeing how experts solve problems, you can see how they use those individual concepts in a real situation. But remember, don't just read those examples passively. Really engage with them. Try to predict the next step. Think about the reasoning, and even try to tweak the example to solve a slightly different problem.
That makes a lot of sense. You're actively taking that knowledge and applying it.
It's like learning to play music. You wouldn't just read about music theory, you'd also practice playing scales, chords, and melodies.
And the more you practice, the better you get, just like anything else. Okay, so we've broken things down into smaller chunks. We're actively engaging with those worked examples, and we're connecting new stuff to what we already know. What else could we do to make learning technical things more efficient?
Well, remember that split attention effect we talked about? That can be a huge obstacle when you're learning something technical. Think about trying to learn from a textbook where the code, the diagrams, and the explanations are all over the place.
Oh, yeah, I hate that. Trying to keep track of everything at once is just, ugh. It's like trying to assemble furniture from instructions where the parts, the diagrams, and the steps are all on separate pieces of paper.
Exactly. That's the split attention effect in action. So, whenever you can, try to find learning materials that are presented in a clear, concise, and integrated way. Look for things that combine the code, the diagrams, and the explanations together in a way that makes sense.
And if you're the one creating learning materials, remember this and do your audience a favor. Don't make them hunt for information. Keep related things together and use visual cues to help them, like headings, bullet points, diagrams, things like that.
And don't forget about that modality effect we talked about. Using both your vision and your hearing can really boost your learning. Instead of just reading a tutorial, try watching a video with visuals and a voiceover.
Or even better, find a live workshop or coding session where you can actually watch an expert do it and ask questions in real time. It's just more engaging, and it can really help things stick in your memory. But of course, even with the best materials and techniques, there's no replacement for good old-fashioned practice.
Oh, absolutely. The more you practice applying these new concepts, the stronger those schemas become, and the easier it gets to remember and use them in new situations.
Okay, so we've been talking about how to make our own learning better. But what about the software we build? How can we use this cognitive load theory to make better systems?
That's where it gets really exciting. At its core, software development is about processing information. And everything we do, from naming our variables to how we structure our code, it all has an impact on cognitive load.
So you're saying that even little things, like what we name our variables, can have a big impact on how easy it is to understand our code.
You got it. By being mindful of cognitive load, we can make choices that make things easy for ourselves, our colleagues, and anyone using our software.
So writing clean code, using good variable names, having good documentation, and designing intuitive interfaces, that's all about reducing that extra cognitive load, right? Makes things easier to understand, use, and maintain.
Exactly. And these ideas go beyond just the code itself. They apply to the tools and processes we use too. Sticking to a consistent coding style, having a clear branching strategy, and automating repetitive tasks can all make a big difference in how much mental effort it takes to develop software.
It's like having a well-organized workspace where you can find everything you need easily.
That's a great analogy. And don't forget about communication, too. How we talk to our colleagues, both verbally and in writing, can make things easier or harder to understand.
So using clear language, giving people the background information they need, and avoiding jargon or overly technical terms, that can all help make sure our messages get across clearly.
Absolutely. And visuals can be super helpful too. Things like diagrams, flowcharts, those kinds of visualizations, they can really help people see the big picture and understand how all the pieces fit together.
It's all about presenting information in a way that makes it easy to understand, right? Reduce the strain, make it clear.
Exactly. It's not just about better code, it's about creating a more mindful and collaborative environment where everyone can do their best work. And this brings us back to that software crisis we were talking about. By using what we know about cognitive load, we can build software that's not just functional, but also understandable, maintainable, and even fun to work with.
That sounds like a pretty amazing goal to me. But it all starts with understanding our own brains and making smart choices that take those limitations into account.
That's the real power of cognitive load theory. It's not just a bunch of abstract ideas, it's a way to think about software development that puts people first.
Okay, so today we've looked at how cognitive load affects our learning and the systems we build. But before we wrap up, I want to circle back to that idea of problem solving, which is such a big part of being a developer. You said earlier that cognitive load theory can actually help us be better problem solvers. How does that work?
Problem solving is all about using our mental resources effectively to figure out solutions. And as we've seen, our working memory is really valuable, but it's limited. Cognitive load theory helps us understand why some problems feel so much harder than others. If a problem involves a lot of complex information, or if we have to juggle a lot of concepts at once, our working memory gets overloaded, and that makes it hard to think clearly and creatively.
So one key to solving problems effectively is to manage that cognitive load.
Exactly. And there are a few things we can do. One is to break down those big, complicated problems into smaller, more manageable pieces. That way, we're not trying to keep track of too much information at once.
Makes sense. What else can we do?
Another really helpful technique is to externalize information whenever you can. Don't try to keep everything in your head. Use diagrams, notes, sketches, even just scribble stuff on a whiteboard if that helps. Whatever gets that information out of your head and into a format that's easier to work with, that frees up your brain power to focus on the problem itself.
That's a good tip. I find that just sketching out a problem visually can really help me understand it better.
It's a really powerful technique. And don't forget about the importance of your own expertise. The more schemas you have in your long-term memory, the less any given problem will tax your working memory. So if you're really struggling with a problem, it might be because you need to build up your knowledge in that area.
So if I'm working on something that involves, let's say, a specific algorithm that I'm not familiar with, it would be helpful to spend some time really understanding that algorithm first before trying to solve the problem.
Exactly. And don't be afraid to ask for help either. Talking through a problem with a colleague or a mentor can often help you see things from a different angle and activate those schemas that you might not have thought of on your own.
Sometimes just explaining a problem out loud to someone else can help me figure out the solution.
It's amazing how helpful that can be. And sometimes the best thing to do when you're stuck is just to step away from the problem for a bit. Let your brain rest and let your subconscious mind work on it in the background.
You mean like take a break, go for a walk, maybe even sleep on it?
Exactly. You might be surprised at the insights that come to you when you come back to the problem with fresh eyes.
So cognitive load theory doesn't just help us understand the challenges of problem solving. It actually gives us tools to overcome those challenges.
Exactly. It reminds us that problem solving isn't just about being super smart or having some special talent. It's a skill you can develop and improve through practice and using these principles.
That's encouraging. Even if someone doesn't think of themselves as a natural problem solver, there's still hope. With some understanding of cognitive load theory and a bit of effort, anyone can become a better problem solver. That is definitely encouraging to hear. But before we finish up this deep dive, I want to talk about something that some of our listeners might be thinking. Cognitive load theory, all this research and experiments, it's still a theory, right? Are there, limitations, criticisms we should know about?
Yeah, that's a great point. It's always smart to be, critical of any theory, no matter how interesting it seems. And cognitive load theory, yeah, it has had its share of critics over the years.
Okay, so what are some of the main criticisms then?
Well, one thing that people point out is that it really focuses on, the thinking part of learning and problem solving, but it sometimes forgets about other stuff. Things like motivation, how you're feeling emotionally, the social context, even individual learning styles. All of that plays a part in how we learn and solve problems, too.
So someone who's really motivated to learn something might be able to handle a bigger cognitive load than someone who's stressed out or just not interested.
Yeah, exactly. And some people just learn better by doing things hands-on rather than studying worked examples, even if that might not be the most efficient way.
So it's not a one-size-fits-all kind of thing. You got to think about the whole person, not just how their brain works.
Exactly. Cognitive load theory, it gives us this great framework, but it's not like a set of rules that have to be followed all the time.
Okay, that makes sense. What about the research itself? Any concerns about how it's done?
Another criticism is that a lot of the research, it uses those simplified experiments in a lab, and those might not really capture how complicated real-world learning and problem-solving can be.
Yeah, true. Trying to recreate, the chaos of real software development in a lab, that's pretty tough.
It is. So while those cognitive load theory principles are really valuable, we got to be careful about, applying them too rigidly.
So where does that leave us then? Should we just ignore cognitive load theory because of all this?
Oh, no, not at all. Even with those limitations, it's still a really helpful way to understand how our brains work and how to make learning and software better. It helps us see those potential problems and gives us ways to fix them. And it reminds us that our brains have limits, and we should design things that respect those limits.
It sounds like a really useful way to look at software development, even if it's not, the complete picture.
Yeah, I think of it as a tool that helps us make software more human-centered.
So what's the big takeaway for everyone listening today?
The big takeaway is this. Cognitive load, it matters. It affects how we learn, how we solve problems, and how we build software. And by understanding that and using the ideas from cognitive load theory, we can make software development more efficient, more enjoyable, and just, better all around.
This has been your deep dive into cognitive load in software development. We hope you found it insightful. Now go forth and code mindfully.